Unit 5, Lesson 2, Similarity in Triangles. Previously, we learned that if two triangles have three pairs of congruent corresponding angles and have corresponding sides proportional, then the triangles are similar. Now we will learn some shortcuts. First one, angle-angle similarity. It says if two angles of one triangle are congruent to two angles in another triangle, then the triangles are similar. Example 1. Explain why the triangles below are similar. Write a similarity statement. So we know that angle A is congruent to angle D because of the right angle theorem. And then right here we can put the tick marks because we know that angle BCA, so BCA is congruent to angle ECD, and that is because of the vertical angle theorem. So therefore we have angle BCA is congruent to angle ECD, and then we have angle A congruent to angle D. So that's two angles in one triangle congruent to two angles in another triangle. So we can say that the two triangles are similar by angle-angle similarity. So we would write triangle ABC is similar to, now we have to see how we're doing this. We started with A, so we have to start with D here. D E C by angle-angle similarity. And that would be the similarity statement. The next theorem, side angle side similarity. It says if two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the triangles are similar. Example 2. Explain why the triangles below are similar. Write a similarity statement. So we're going to take the smaller side in this triangle, which is TX, is 12 over.
What's 2? Mom, can I say something to you?
Hold on a second.
I'm going back with you.
Okay. Just shh. And then we'll be okay. Okay. Okay, so we're starting with TX over here, so it's 12. So the corresponding side in this triangle would be VX, and that is 16. So 12 over 16, and we can simplify that to 3/4. So then we're going to take the 15, which is UX, and the corresponding side in this triangle would be WX, which is 20. So we're going to put 15 over 20, and we can simplify that to 3/4. So they are proportional. And then we also have the vertical angles here, and so that is the angle that is in between the sides. So we can say that the two triangles are similar by side angle side similarity. So to write the similarity statement, we would say triangle TXU is similar to triangle VXW by side angle side similarity. And that would be the answer. The next theorem, side similarity. If the three sides of one triangle are proportional to three corresponding sides of another triangle, then the triangles are similar by side similarity. So example 3 says, explain why the triangles below are similar. Write a similarity statement. So if we start, hold on a second. Okay, so we're going to start with the smaller triangle. So DE is 10. Now if you flip this triangle around, you can see that the corresponding side to that in this triangle would be AC. So you have 10 over 14, so we can simplify that to 5 over 7. Then we'll take the 15, which is FE, so we have 15 over, and then again, if you rotate this triangle, you can see that the corresponding side here would be AB, so that's over 21, and again, that can be simplified to 5/7. And then the last, so we have 20, which is FD, which is the last side, corresponds to CB, so that would be 28, and again, you can simplify to 5 over 7. So then you can say that all three sides are proportional, so the two triangles are similar by side similarity. So to write the statement, you would say triangle CAB is similar to triangle DEF by side similarity. And that would be your answer. Next page, you can apply angle similarity, side similarity, and side similarity to find the lengths of sides in similar triangles. Example 4, if the triangles are similar, find x. So again, if you rotate this triangle, you can see it's easier to see which sides correspond with each other. So if we start with the 5 to set it up, we would say 5 over, so this side corresponds with this side, so that would be 5 over x equals, now it's important that the numerators come from the same triangle, so you have to put 7 up here, and then the 10 would go in the denominator. The numerators have to come from the same triangle. So this is how we would set it up. 5 over x equals 7 over 10. So then when you solve, you cross multiply. 7x equals 5 times 10. 7x equals 50. And then you would divide by 7, divide by 7. If you do that out on a calculator, x comes out to about 7.14.
I was so into
again, the triangles are similar. We know that we have the angles here and the right angles, so they're similar by angle similarity. Example 5. If the triangles are similar, find x. So again, the two triangles here are EBA, which is inside of triangle DAC. So you have the right angles, and then they share an angle here, so we know they're similar by angle similarity. So to find x, we need to set up our ratio. So we have 5, and this one's a little bit easier to see than example 4, but this side here, EB, corresponds with DC, so it would be 5 over x equals, and then it would be 9, so the numerators have to come from the same triangle, so you have the 9 in the numerator, but then on the It's not going to be 3 on the bottom because it's the whole length. CA is this whole thing, so you have to add these two together. So it would be 12, 9 over 12. And then you can cross multiply and solve for x. So you have 9x equals 5 times 12. 9x equals 60, divide by 9. X equals is about 6.67. Moving on to the last example. Example 6. If the triangles are similar, find RT and ST. So again, they share an angle R, and angle S is congruent to angle T, so they're similar by angle similarity. So we need to set up our problem. So we can see that we have SV, so it's 8, over, and then it has to be TU, so that would be 12 in the denominator, equals, now the numerators have to come from the same triangle, so I have to put 10 over, and then it would be for the big triangle, it's RT. So then we can say, we cross multiply, so 8 times RT equals 12 times 10. ART equals 120. Divide by 8. Divide by 8. Divide both sides by 8. So then RT equals 15. So then to find ST, we know that this segment plus this segment equals the whole. So we would say RS plus ST equals RT. So we know RS is 10 plus ST equals RT, which we just found is 15. Subtract the 10, subtract the 10, ST equals 5. Have a good day.